First off, I must congratulate you on successfully completing the third chapter of the ISTQB Mobile Application Testing certificate. Quite an achievement, I must say. And I know it's been a long journey, but hopefully you found it both challenging and rewarding. We have covered a lot of ground, from different mobile-specific test types to heuristics to test approaches and much more. And now you are equipped with a solid knowledge base. Very well, so welcome to Chapter 4, and now here's some great news. Chapter 4 and 5 are the fun part of the syllabus, in my opinion. We are going to dive into some really interesting topics, and the best part, they are not only fun but also easier. And you'll move through them quickly, so buckle up, and it's going to be a smooth ride, hopefully. Today we are starting with an interesting topic, development platforms for mobile applications. So are you ready? Yes? Me too. So let's roll. Alright, so when we talk about development platforms for mobile applications, you might think it's something just for developers, but it's not. It's closely related to the development process, which means platforms are used not only by developers but also by testers like us. They play a crucial role in how mobile apps are built, tested, and maintained. So, what is a development platform in the first place? Well, a development platform is essentially a set of tools and software that both developers and testers use to create and test mobile applications. This includes the programs that help us write code, the environments in which apps are executed, and the testing tools we use to ensure they function properly. Think of it as the complete toolkit needed to go from an idea to a fully functioning application. Now, let's focus on the word platform. I believe we have actually come across this term multiple times in different contexts. But here it refers to something very specific. Platform is the underlying software and hardware infrastructure that provide the environment for mobile applications to run. It's what allows your mobile app to function in real world. This word, platform, has four main components that shape it. So let's take a quick look at them. First, we got the operating systems. These are the media that mobile apps run on, like Android and iOS. These two dominate the mobile app world, and testing for each requires understanding their unique environments. Secondly, development tools. Now, this includes software development kits or SDKs, which themselves include the IDEs or the integrated development environments. Also, development tools include frameworks, which are libraries in the form of reusable code that makes development faster and easier. Next, the app stores where users can download and install their mobile applications, like the Apple App Store and the Google Play Store. As testers, we are required to ensure that our apps meet the criteria required by these stores before release. Do you remember what testing is conducted to make sure of the compliance with the actual criteria? Revisit Chapter 3 if you don't. Lastly, there is hardware. These are the physical devices, such as smartphones, tablets, and the processors inside them. Testing across different hardware configurations ensure compatibility and performance across a variety of devices. Alright, now let's dive a bit deeper into something commonly used in the mobile app development and testing worlds, IDEs, or Integrated Development Environments. Simply, an IDE is a single workspace where you can design, code, compile, test, and even monitor your app's performance. So, what are the common functions and capabilities of an IDE? Of course, what I mean here by IDEs are the mobile IDEs, as we are going to see in a moment. Anyway, mobile IDEs offers a vast range of capabilities that help us develop and test mobile apps. And let's take a look at some of them. So IDEs are very helpful in mobile app design. IDEs allow us to create and arrange app interfaces visually. You can drag and drop UI elements like buttons and text fields and see how they will appear on the app without writing a single line of code for that part. Coding is another major function of IDEs. They provide a workspace for writing and editing the code. This is where developers and testers spend a lot of time here, building the logic that makes the app function. Also, after coding, IDEs also translate the implementation code into executable mobile apps. This step turns the code into something the mobile device can understand and run. Great, now I think you want to quickly check how your app performs on a test device, right? IDEs make it easy to install and remove apps on the test device with just few clicks. IDEs also track, or let's say monitor, app performance or resources, helping to keep an eye on things like memory consumption and processing power. Now, if you don't have access to every mobile device in the world, don't worry. IDEs come with built-in device emulators, allowing you to simulate devices and test apps without needing physical hardware. Logging is another great feature of IDEs. So during app execution, IDEs record app behavior and errors, which is critical for troubleshooting and debugging. All of these features like monitoring, emulating, logging, etc. help us as testers to conduct the test process efficiently. IDEs not only help in manual testing, but also in automated testing. Very well, now let's talk about the types and examples of IDEs. Commonly there are two main categories, normal IDEs and mobile IDEs. General IDEs are general-purpose IDEs used for various kinds of development, especially web and desktop applications. Examples are Visual Studio and Atom. Then we have the mobile IDEs. These are the specialized IDEs used specifically for developing mobile applications, and let's break this category into two further types: native IDEs and cross-platform IDEs. Starting with native IDEs, they are designed for building apps specifically for a particular platform, like Android or iOS. For instance, Android Studio is an IDE designed to create Android apps and is fundamentally built to fully support the native features and the hardware of the Android ecosystem. For iOS development, Xcode is the go-to IDE. It provides all the necessary tools to build iPhone and iPad applications, offering seamless integration with Apple's APIs and framework. Now, a brilliant and relatively new method of developing mobile applications is using cross-platform IDEs. Technically, these aren't standalone IDEs, but rather frameworks that are installed on other IDEs like Visual Studio to allow for cross-platform development, of course. Two popular examples are Flutter and React Native. These cross-platform technologies allow for easier development as it eliminates the necessity for writing one code for Android and another separate code for iOS. So it's relatively easier, but still requires coding. Simply, the developer will write a single code and the IDE will export two versions of the app, one for Android and one for iOS. Very brilliant, I must say. Let's quickly and frankly discuss the difference between native development technologies and cross platform technologies. This is out of the scope of this lecture, but we will tackle this in simple terms. So, it's better to use native IDEs when your app needs to take full advantage of the platform specific features. For instance, if you are developing an app that needs deep integration with Android or iOS hardware, like using the camera, GPS, or other sensors, native development IDEs will give you the best performance and access to those features. However, development is tied to one platform. So if you want the app on both Android and iOS, you will need to develop two separate apps. This is, of course, translate into more time and resource needed. On the other hand, cross-platform technologies are best when you want to build apps for multiple platforms. I mean Android and iOS, with a single code base. This reduces development time and cost, making them a popular choice for startups and businesses looking to reach both platforms quickly. Nevertheless, this technology has its own limitations, as they do not match the performance of native apps, especially for complex or resource intensive applications. Plus, some platform specific features might not be fully supported, requiring additional workarounds. So, I think we've reached the end of this lecture, and thank you all for your attention. You have been great as always. I know this was a lot of information about platforms and IDEs, but just think of it this way. IDEs are like the Swiss Army knives for app development and testing. They've got everything you need, except, of course, the actual knife. Now get yourselves ready for the quiz and the exam sample, and don't worry, it's going to be easy peasy if you paid attention today. Good luck, and I'll see you all the next lecture. Take care.